Okay, so welcome to Physics for Real, and today we're going to have a look at Snell's Law. So if we flip to this slide here, we can use this to help us. So here we've got a ray of light here that is passing from, we're going to say that this is air. Okay, so it's passing from air into glass. And as it does that, you can see that it bends towards the normal line, okay? And why do we say that? Well, this angle here is bigger than this angle here. And I'm going to call the initial angle, which we normally call the angle of incidence, I'm going to call that theta 1. And then, it's not written very well, is it? Let's do that again. So if we write that as, change the thickness of this pen, yes, we're going to write that angle there as theta 1. And we're going to say that this angle here is equal to, is theta 2, okay? So often we call that the angle of incidence and the angle of refraction, but in this case we're going to call them theta 1 and theta 2. Okay, so as we said, the light is bending towards the normal, and the reason for that is that glass is more dense than air. And we usually take account of this in terms of what we call refractive index. So the refractive index of air would be equal to the speed of light in a vacuum divided by the speed of light in air. So the refractive index of air is essentially the ratio of the speed of light in a vacuum to the speed of light in air. And then if we were to look at the refractive index of glass, N2, it's just going to be equal to the speed of light in a vacuum divided by the speed of light in glass. So we'll come back to those in a minute. And then basically Snell's law says this. Snell's law says that sine of the angle of incidence divided by sine of the angle of refraction is equal to a constant. Okay, so it's equal to a constant, and that constant turns out to be the following. So basically, sine theta 1 over sine theta 2 is equal to the refractive index of each of the materials divided by one another. So Snell's law says that the sine of the angle of incidence divided by sine of the angle of refraction is equal to the refractive index of the material that the light is passing into divided by the refractive index of the material that light is passing out of. Okay, and we can write this in another way as well. So often we write this as n1 sine theta 1 is equal to n2 sine theta 2. So that's an alternative way of writing the same equation. Okay, and then there's another way we can write this as well, and it works as follows. So n2 divided by n1, well, we know that n2 is that, and n1 is this. So we can substitute those values in to this equation. And we can write c over v2, because that's n2 divided by c over v1. Now, when you divide two fractions, you can write that like this. So the numerator multiplied by the denominator flipped over, so to speak. And then you'll see that these two things cancel, and we can write this as n2 over n1 is equal to v1 over v2. So all that's saying is that the refractive index in glass, in this instance, divided by the refractive index in air is equal to the speed of light in air divided by the speed of light in glass. So that means then we can finally write our equation for Snell's law as sine theta 1 over sine theta 2 is equal to v1 over v2. So those really are the three main ways we can write this equation. We can write it like that, we can rearrange it like that, or we can write it like that. Okay? So all that Snell's law says, in summary, is that the sine of the angle of incidence divided by the sine of the angle of refraction is equal to a constant, which can take a couple of different forms. This form here, the refractive indices divided by one another, or this form here, the speeds in the different materials divided by one another. And that's basically Snell's law.